We will now talk about how to determine nuclear equations. Once again, you're going to start thinking of them as a math problem where one side has to equal the other, just as you would if it was a balanced equation. But remember, we're dealing with the nucleus this time, not how many atoms there are. In a balanced nuclear equation, particles are emitted from the nucleus. So remember, this is the center of the atom. The mass number and the atomic number are the things that can change. Remember, the mass number are the protons and the neutrons added together, whereas the atomic number is just the protons. Because of this, the mass number is always going to be bigger. It's also going to be the number on the top. And this is always the number on the bottom. The sum of the mass numbers and the sum of the atomic numbers are equal from one side of the equation to the other. For instance, here we have 251. It broke down into this new element and a helium, an alpha particle. 247 plus 4 is equal to 251. On the bottom of it, the original atomic number is 98. The new atomic number is 96 once those two are taken out. Those two protons are taken out. Once again, that equals 98. They have to equal each other. The letters changed. And that is because the atomic number changed. So atomic symbol has to follow the atomic number. So the atomic symbol is because of the number on the bottom, not the number on the top. So when you're looking at the periodic table, that's what you're going to be looking for. So alpha decay, notice the word decay. That means it's given off, which means it's going to be on the right-hand side of the arrow. It emits an alpha particle, which we learned previously that an alpha particle is a helium 4 over 2. 4 is the mass number, 2 is the atomic number, and that's given off. So if we start off with 238, we take 4 out of it, we're left over with 234. Start off with 92, take 2 out of it, we're left over with 90. The new nucleus is because the new element is because of the number of protons, not the mass number. So let's take a look at this one. Rn-222. What that means is if we were to write this out, 222 is going to be on the top, because that's the mass number, just like up here. So that 222 is the mass number. We have to look on the periodic table to figure out what the bottom number is. Rn is 86. So that bottom number here is going to be 86. Alpha particle decay, meaning it's given off. So 4,2He is the alpha particle. And whatever remains is what's left over. So 222 minus 4 is 218. 86 on the bottom minus 2 is equal to 84. To figure out what the new element is, we look on the periodic table and we look for 84. We notice it's PO, polonium. And that's how you solve it. The top numbers have to equal each other. The bottom numbers have to equal each other. Remember, the arrow acts as if an equal sign. A beta particle, once again we're talking about emissions, giving off. We learned earlier beta particle is an electron that comes out of the nucleus. So if we're looking at here, the top number 14, that 0 means that there's no change, so it's still going to be 14. The bottom number is 6. Because of that negative charge, think of it as an equal sign, is equal to x plus -1. So that's really 6 is equal to x minus 1. Add 1 to both sides, and that's how we get the 7 here. Then when you look at the periodic table, 7 is nitrogen, and that's where they got the N from. So let's do this again. K42, that's the mass number. We have to look on the periodic table for the atomic number, which is 19. And it's beta emission, so we're going to have a beta particle. Emission means it's on the right hand side of the arrow. So 42 is equal to 0 plus x. X is equal to 42. So that means this top number is still 42. The bottom number, 19, is equal to -1 plus x. So we add 1 to both sides. The bottom number is 20. The new element is now calcium. Another one, beta decay. CO60. Looking on the periodic table, CO is right here. It's number 27. Beta decay means it's on the right hand side, and beta is this symbol. 60 is equal to 0 plus, well, that means x would still have to be 60. The bottom one's the hard one. 27 is equal to -1 plus x. Add 1 to both sides, and you get x is equal to 28. Which puts us at nickel. Positron emission is a proton that's been converted to both a neutron and a positron. So you've taken a proton out of the nucleus, and it's broken down into its components. So you're left over with a neutron, but this actually leaves the compound, the element. So once again, this is our positron symbol. Emission means that's on the right-hand side of the arrow. Gamma radiation, we talked before about how gamma radiation is the beta particle and the positron combining to form energy, and they cancel the charges out, which is why it's 0 here. Notice there's no change to the numbers here. Everything stays the same. You just have energy that's being given off, which makes it more stable. So a summary of the types of radiation, once again: alpha, 4/2 helium, and it changes into a new element. Beta, 0/-1, changes the atomic number, the mass number stays the same. Positron, 0/+1, once again mass number stays the same, atomic number changes. And then gamma, there is no change in either of them, but it's more stable because it's giving off the extra energy. So how are these radioactive isotopes produced? When a stable nucleus is converted to a radioactive nucleus by bombarding a small particle. So here's a small particle here. They collide and build something bigger. This is called transmutation. This is just one way of it being produced. So here's another example. The small particle here is a neutron. So if we look here, we want to know what that is. So 98 plus 1, I'm using the arrow as an equal sign, x, whatever that is, plus 4. So that means 99 is equal to x plus 4. Subtract 4 from both sides, and that becomes 95 on the top. On the bottom, we have 27 plus 0 is equal to x, whatever that is, plus 2. So that's 27 is equal to x plus 2. That means x is 25 on the bottom. Looking at the periodic table, we look for 25. Mn. Once again, we're always looking for the bottom number, not the top number. But you notice it's the same pattern over and over and over again. The top lines have to equal each other. The bottom lines have to equal each other. And that is how you balance nuclear equations.